Okay, so right now let's solve exponential equations using logarithms. So these questions right here, they're not even close to being solvable using related bases. So when you see this, you immediately know that you're most likely going to be using logarithms because we have x's in the exponents here and we're going to try and solve for x. So there's that cool property of logs where if we had log, for example, of 2 to the x, this is the same as x times the log of 2, and the log of 2 is just a constant. So now that we have x multiplying out front, we can divide by log 2 and figure out what x is. So that's kind of the reasoning behind it. If we have this equation right here, we're going to have to take the log of both sides, right? Because x's are in the exponents. So this is log of 2 to the x, 5 to the x, equal to the log of 2 to the 5th times x minus 1, or times 10 to the power of x minus 1 to the 6th. So let's simplify this however we can. One way we can simplify this is splitting up the things that are multiplying. So the log of 2 to the x plus 5 to the x is the log of 2 to the x plus the log of 5 to the x. And we can also bring that x out in front. So this will be x times the log of 2 plus x times the log of 5. That's going to be equal to the log of 2 over 5 plus 6 times the log of, well, actually, we can simplify that exponent as well. So 10 to the power of x minus 1 to the power of 6. The 6 and x minus 1 are just multiplying. So this is really times 10 to the power of 6x minus 6, right? They just kind of factored it out. So this will be plus, let's see, 6x log 10 minus 6 log 10. Okay, that's what it's going to end up being, because if we took the log of 6x, the log of 10 to the power of 6x minus 6, we'd bring that out in front, so it would be 6x minus 6 times the log of 10. Yeah, so this would be 6x log 10 minus 6 log 10. Okay, so now that we kind of split everything up, let's simplify however we can. Let's move everything with an x to one side. I mentioned it before, but I'm just going to kind of keep reiterating that. Since we use logarithms, now the x's are all multiplying in front of some constant, the log of a number. So let's move all the x's to one side, then we can factor out an x. So we get, I'll just kind of copy this down here. We get x log 2, right, plus x log 5. And then we're going to get minus 6x log 10. That's going to be equal to the log of 2 over 5. Right, this 6x log 10 is gone. Then we get minus 6 log 10. Okay, we can factor out an x on this side. So we get x times log 2 plus log 5 minus 6 log 10. That's going to be equal to the log of 2 over 5 minus 6 log 10. Okay, if we simplify this here, right, let's do the left first. Since these logarithms are subtracting and they're both in base 10, right, since they have the same base, that means we can use our property log of something minus log of something else is just the log of the first thing over the second thing. So 6 log 10, that's the same as log of 10 to the 6th. So simplifying this will just be the log of 2/5, right? Or just 2 over 5 times 10 to the 6th. Okay, so that's the right side if we simplified it. And on the left side here, this is the same as x, right? Since these are adding, this is going to be the same as log of 2 times 5. So the log of 10 times, or sorry, not times, this will be divided by, because we're subtracting here, the log of 10 over 10 to the power of 6, right? This will just be 10 to the negative 5. And right here we just get the log, same thing, of 2 over 5 times 10 to the 6th. right? The log of 10 over 10 to the 6th, that's just the log of 10 to the negative 5. So this will just be negative 5. So we get negative 5x equals, well, we're going to have to use a calculator for this one. So the log, let's do 5 times 10 to the power of 6. Big number there, 2 divided by that. Okay, so we're going to take the log of that. That's going to be negative 6.4. So negative 6 point, I'll go about negative 6.4. If we divide both sides by negative 5, right, we get that x is equal to 1.28 approximately. So if we were to plug in x, or if we were to plug in 1.28 for everywhere we saw x, we would get that this is the answer there. So we would get that the left side equals the right side. Okay, so for this one, right, we're going to use our properties of logs again. Take the log of both sides. We're going to get 2 log x 2 log 0.25 minus x log 0.25. So we're just distributing this x and the 2 into the log 0.25 once we bring this exponent out to the front. So that's going to be equal to, right, if we have these two things dividing over here, these two things are dividing, right, and we take the log of them, it's the same as the log of 304 minus the log of 2 to the x plus 4. Right, because when we have two logs with the same base subtracting, we can kind of confine it down to this form there. Now we're doing the opposite, we're expanding. And since we still have this x in the exponent, we're going to use our property of logs and bring that out front. So this is going to be minus x log 2 minus 4 log 2. Minus x log 2 minus 4 log 2. Okay, now if we simplify this however we can, right, we want everything with x's on one side. So I'll go negative x log 0.25 plus x log 2 is equal to log 304, right, minus 4 log 2 minus 2 log 0.25. Okay, now if we use kind of our logarithm laws and we factor out an x, we'll get x equals negative log 0.25 plus log 2 equals the log of, well, we can combine this to make one log. So it'll be the log of 304 over 2 to the power of 4 times 0.25 squared, right? Because we're subtracting this, so we'll get log 304 over log of 2 to the 4th if we bring this 4 back up to the exponent. And then we have to divide that further by the we divide that further by 0.25 squared if we move this back to the exponent. So this would be 304 over 2 to the 4th times 0.25 squared. Take the log of that, right? And then we want x, so we divide both sides by this expression right here. I'm not going to rewrite it all, but it's going to be the log of 304 over 2 to the 4 times 0.25 squared over negative log 0.25 plus log 2. And if we wanted to, we could write this as the base of the log and then the argument. It doesn't matter a whole lot, but in the end, these are all just constants, so I'll figure out what that is right now. So 304 divided by 2 to the power of 4 times 0.25 squared. Oh, that's just 304. Okay, so this is going to be 0 on the top. Okay, so if we had 2 to the 4th times 0.25 squared, that's interesting, that's just 1. So this is going to be the log of 304, I guess. That is very interesting. Okay. So this is just the log of 304. divided by negative log 0.25. So that's 0.6 plus the log of 2. This is over 0.9, so we're going to get the log of 304 divided by 0.9. That's going to be 2.75. So x is going to be 2.75. If we plug that in, right, where we saw x for, this question here, we get the left side equals the right side. Now let's do one more here. 3 to the power of negative 9x times 3 to the power of negative x plus 1 over 3 to the 7th is a half. So like we did in the last ones, we're going to take the log of both sides because x is in the exponent. Okay, so we're going to say that the log of 3 to the negative 9x times 3 to the negative x plus 1. Whoops. Hold on, 3 to the negative x plus 1 divided by 3 to the 7 equals a half. Taking the logarithm, so log of a half. Okay, whenever we have this kind of weird situation going on here, before we can bring the exponents out, we have to split up these logarithms so that they're the log of just one thing. Okay, so since these are multiplying on the top, this is going to be the log of 3 to the negative 9x plus the log of 3 to the negative x plus 1. And then we're dividing by 3 to the 7, so we're going to say minus the log of 3 to the 7 equals the log of a half. Okay, now we can use our properties. We're going to say negative 9x log 3 plus, this is negative x plus 1, so it's going to be, instead of plus, it'll be minus x log 3 plus 1 log 3, so just plus log 3, and then minus log 3 to the 7, so I'm going to say minus 7 log 3, doesn't really matter there because it's a constant, but we'll just do it anyway, equals the log of a half. Okay, we're going to move everything that's a number to the other side, and notice how we have log 3 here, negative 7 log here, or negative 7 log 3 here, so it's going to be negative 6 log 3. So it's going to be, we can factor out an x, negative 9 log 3. Oh, these are all log 3's except this one. That's interesting. So negative 9 log 3 minus, I guess it's just minus log 3 plus log 3 equals log of a half plus 7 log 3. Oh no, that would be, plus, hold on. I kind of messed up here. So if you factor out an x, that would take care of this negative 9x. So it's negative 9 there. Negative x, this would be negative 1. Okay, that's what I did. So log 3 minus 7 log 3 is going to be negative 6 log 3. If we add that on both sides, we'll get 6 log 3. Why am I writing? Oh, I'm like dying. 6 log 3 plus log of a half. We can simplify this inside to negative 10 log 3. So this will be x equals 6 log 3 plus log of a half over negative 10 log 3. Okay, and we're just going to use our calculator here from now on. So 6 times the log of 3, right, that's going to be 2.86. We're going to take that and we're going to add the log of a half. We're going to take that, divide it by negative 10 log 3, negative 0.537. So if we were to plug that in for x, you would get the left side equals the right side. So that's how we can solve exponential equations with logarithms. And in my next video, I'm going to talk about solving logarithmic equations. So instead of starting with exponentials, we're going to start with logs.